You see the essential parts of any C program. In this video, we will learn how to sort the array elements using a new method. That method is named as selection sort. So first let us understand the mechanism of selection sort. To understand that, I have taken an example and that example is in front of you. You see under the blue background here there is an array of 6 elements, and elements are 12, 19, 8, minus 5, 78, and at the end 21. And above these numbers you see integers in red color, and these integers are nothing but the index numbers. These are indices. Indices means, you know, suppose array name is A, then A0. A0 means this 12. And accordingly A1 will be 19, A2 I show you by typing. Suppose array name is A, this A, then A0 will be 12, A1 will be 19, and so on. And A5, the last element, A5 will be 21. So this is the work of index. Now we have to sort the elements. You know that the elements are not sorted. Here you see these are randomly typed, and in this, as I said, that we will learn to sort the array elements using selection sort. Now let us try to understand what is selection sort. For that, we assume the first element. You see the first element is 12. We assume the first element to be the smallest element. However, it is not. For the time being, I am assuming it the smallest element, and at the same time we assume its index. You see index is 0, so we can type here 0, and accordingly you can type here A0, A0. Okay, now we proceed. First we have seen this 12. Now the second element, we go for the second element. Second element is 19. We compare with the previous one. 19 is not smaller than 12. We are searching the smallest element. 19 is not smaller than 12, so this thing, the smallest and its index, both will remain under 0. Now we go for the third element, this element 8, and 8 is smaller than 12. So now it will change its place, and here it will reside, and the index is now 2. So here index will be updated and it will be 2. Accordingly, this will come here, and this 0 will be updated and here will be 2. Now we go for the third element, fourth element, that is -5. And -5 is smaller than 8, so it will again, it will be updated. S, the value of S and T will be updated. Here will be now 3 and here will be 3. Now the next element is 78, and 78 is not smaller than -5, so these two will remain at at their places. So we go for the last one, 21. Still you see 21 is not smaller than -5. So our one run is complete. We have completed the visiting of elements. We have visited all the elements and got our smallest element, and that element is -5. And if we arrange the elements in ascending order, then this means that the smallest element should be at this place, that is at 12, that is at the 0 index. So here will be -5 and here will be 12. In other words, in programming language, we can say that the smallest element and the first element have interchanged their positions. Since the smallest element has gone to the first place, so S will be there. Accordingly, the position will be there. Now we repeat the same process. Here will be 0 and here will be 0. We do this after visiting all the elements. Now we do the same. Now it is time to search the next smallest element. In other words, we may say the same thing in other word, that we have to consider this reduced matrix. You see the matrix, not matrix, an array. You see here is an array under the blue background, and this array is smaller than the previous one. We have to consider this array and we have to find the smallest element in this reduced array, and after finding, we have to swap that number and we have to keep it at the first place. And I am not going to show you the steps because I have already shown you the steps, and in the second step, here will be 8 because 8 is the smallest element, and here will be 19. Now you see that these two elements are sorted. First, only minus 5 was sorted because after first complete run we have kept the smallest element at the first position. Accordingly, in the second complete run, you will get the second largest element, and proceeding in the same way, you will you will get and you will get an entirely sorted array. So, since you have got two elements, the smallest one and the second smallest one, so we can make these two green. So initially there was only one sorted element, now it is two sorted elements in green, and for the third time in the same way if you go for the third time for this reduced array, you may note that the array is being reduced after each complete run. Earlier the reduced array was of size 5, now it is of size 4. Thereafter it will be of size 3, 2, 1. When it is of size 1, then our entire array will be sorted. This is the mechanism of selection sort. Now let us go for the code for the program. Here is the essential part of any C program. I am going to paste something, and this part is very simple. You can see this part in most of the programs related to an array. This parts is nothing but to take the size and to take the array elements. Now I go for the sorting part. Now I am going to type those part of the code which is responsible for the sorting. And you know, as I have shown to you that first we assume the first element as the smallest element, and at the same time we stored its index. Index is 0, so 0 is being stored in T. Thereafter we run a for loop to visit all the elements. Since the first element has been assumed as the smallest element, so we start the index from 1, and this will go up to n minus 1, and after one visit the index will be increased by 1, because you know indices are at a distance 1. Now there will be a comparison, because I have assumed a0 to be smallest, but it may not be, because as you proceed, as you visit, there may be a chance that you get a smaller, even smaller than this s. So accordingly we have to compare. So here we compare aj. If aj is less than s, this means that there is a smaller element than s. In that case we update the smallest element. Now the smallest element will be aj, because aj is smaller than s, and at the same time we store the index in T. So I have done updating s as well as storing the index. Now you know, when you got the smallest element, now the time comes to now the time comes to swap the elements, and for that we take a temp variable. Under this we store ai, sorry, a0, the first element, and this first element is given the value, the smallest value, that is s, and the position containing the smallest value, that is 80, will now store the value under temp, because this temp is storing the value of the first index, the value of the element of that element which belongs to first index, that is 0 index. So that value will be given to 80. Now searching the smallest element as well as swapping is complete, but I have not done the work for the reduced array, because after one complete visit you get the smallest element, not all the elements. You have to search the second smallest element, the third smallest element. For that we have to run one more for loop. This means that in this program we use nested for loop. Okay, for that we keep this thing under curly bracket, these things. I have kept the part of the code which is responsible for the sorting, this part, under the pair of curly bracket, and this whole part will be the body of outer for loop, and that for loop I am typing now: I equals to 0, I will be less than n, and I will be increased by 1 after one complete run. You may notice that for I equals to 0 it is 0, but I changes its value after one complete run, after one complete run of inner for loop, this for loop. When the first run is complete, then this the value of I will be 1. So to generalize, to work for the array as well as for the reduced arrays, we have to keep here I. Initial value of I is 0, so it will work for a0 as well, and accordingly here I, in the same way here also will be I. Now I think our code is complete. Now there is a third part, there will be a third part, you know, this part is responsible for the output. It will show you the output, and so here we type the sorted array elements R. Same thing is not typed again and again, it is copied and pasted. So I go for copy and paste. Here I paste, but there will be certain modification because this time I have to show the output. So here will be printf function, and there is no need to type ampersand inside printf function. So you see, now I show you the entire program. This is the upper half of this program, this is the lower half of this program, and now I go to execute the program. Let us execute this program. Okay, it says enter the size, but before executing, here I take \t because we have to show the elements at a tab distance. Now I go for the execution. Here it says enter the size. You see, now enter the size. You may take any size. I take 7. So I have to insert 7 integers: 78, 0, 9, minus 45, 56, 89, 34. And you see that we got the result, but this array is not sorted. You see the 0, the last element is 0. So there is some error, some mistake in this program. What is the mistake? Let us observe. Okay, you see that I have taken here, earlier here was 0. I keep it thereafter, after some time I make it I, and accordingly here will be I plus 1, not 1, I plus 1, because if you take I equals to 0, initial value of I, so here will be 0, here will be 0, and here will be 1. 0 plus 1, 1. So I had not taken I here, so it was showing an error, a fault. Now I think it is okay. It is saying enter the size. So I place this time 10. So I have to insert 10 data, 10 integers: 78, minus 9, 0, 7, 6, 7, 4, 5, 3, 4, 900. You can take any 10 integers: minus 3, 4, 5, 7, 2, 3, and now you see this is the output. I have inserted these values. Okay, these values. This is the input, and now this is the output. This is the output, and you see the numbers minus 3, 4, 5, minus 9, 0, 7, 23, 34, 45, 78, 767 and 900. These all are in sorted form. So we got a sorted array. So code our code is okay. So I show you the entire code once more. You see, this is the upper half of the code, and this is the lower half of this code. Okay, try to get all the steps of this program. If you do not get any part of this program, write your problem in the comment box of this video.